I'm going to explain factorization now. The first thing to remember in factorization is that you must end up with brackets. There's a good way to remember what are you doing in factorization is that you end up with a bracket. That's where you're moving towards. Now, in factorization, we would like to take out a common factor from each term in your expression. In the algebraic expression, here are two terms, and we ask what is the common number, or the highest number or constant we can take out from each term, and what is the highest variable of each variable we can take out from each term in this expression. In this case, we can see that we can take out 2 and 2 from this expression, and what you are left with after you've taken out the 2x from the first term, you are left with x, and from the second term, if you take out 2 from plus 2y, you are left with plus y. And you probably noticed that I say you take out, but in reality you divide what you've taken out into each term. So I've taken out 2 from 2x, so I divide the 2 that I've taken out into 2x, and what are you left with? You're left with x, and that's why we write the x there. It's the same with the plus 2y. If you divide the 2 in there, you are left with plus y. That's why that one says plus y. Let's look at another example. If you have mn minus nk, then our first question again is what variable, or the highest variable, we can take out from each term here, and in this case it will be n. So if we take out n from there, or divide n into that, what are we left with? We're left with m. And if you divide the n into, well, actually, don't forget the minus. If you divide the n into minus nk, you're left with minus k. Another example, this is a more difficult example. Of course, we are now also dealing with exponents, and that's why it's important that you work through your exponents before you do factorization. Is now that so what is the highest a we can take out from each term, and what is the highest b that we can take out from each term? And again, if you don't see an exponent, the exponent is 1. Well, let's look at the a's first. Here, a to the power 5 means a times a times a times a. A squared means a times a. Now we can see the largest amount of a's we can take out is 2 a's. Now if you take out, you'll see what we are left with later on, but if you take out 2 a's from the first a's, then you are going to be left with 3 a's. Here you're not actually going to be left with a's, but anyway, what is the highest number of a's we can take out? Well, it's 2a, so it's a squared we take out from both terms. Then from both terms, what's the highest b we take out? We take b from both terms, we take it out. So what are we left with? Well, if we take a to the power 5 and you take out a squared from the first a squared you take out from the first term, you're left with a to the power 3. And if you take out b from the first term, then you are left with b squared. Yeah, because you've only taken out or divided 1b into b to the power 3. If you look at the second term, we've actually divided a squared b into a squared b, so you're left with a squared b divided by a squared b, and remember that minus in front of the term there, so you're left with minus 1, and that's why we put it like this. So this is what is left in the brackets after we've taken out a squared b. Let's look at another example, and this time is 12p plus 18pq. Here we ask again, what is the largest number? The largest number, the lowest common denominator, the lowest number we can take out from each term here, and in this case it will be 6. Because so 6 can divide into 12 and 6 can divide into 18. Because we can't take out 12, because if we divide 12 into the 18, then we have 1,5, and when you do factorization, you don't want to be left with decimals. So if we've taken out the 6 and out, and we can see from both terms we can take out a p as well. So if we divide the 6 or take out the 6 from the 12, we are left with 2. If we take out the p from the 12p, well, there's no more p's left. And if we take now, we can also again write it like this, and you can do it for the first term as well. If you take out 6p from here, you divide the p's into each other, and 18 divided by 6 is 3, so you're left with plus 3q. And again, you have the brackets, you end up with brackets, and that's what you do with factorization. You take out the common factor and you end up with brackets. Here, 3x minus y, this is our next example, plus tx minus y. Here, if you can take out a common factor of x minus y. You see there are two terms here, 3x minus y plus t. The t almost looks like a plus, and the tx minus y. So you have two terms here, 3x minus y, tx minus y. Here you can see the common factor will be x minus y you can take out. So you write the x minus y like this. And I keep the brackets because it's actually the brackets I take out. And what are left? Well, we start with what we are left with a bracket. So what are we left with? Well, if we took out x minus y from this term, you are left with 3. And for the second term, you are left with t.